Welcome, Don Platt. It's been a while. It's nice to see you even on Zoom. For our listeners, tell us a little bit about who you are and how you came to be involved with space.
Sure. Yeah, I'm Dr. Don Platt, and I've been involved in space for, I guess, about 30 years, actually, both from an academic point of view and then also a space entrepreneurship point of view. And I've always actually loved space. I can remember back maybe 5 or 6 years old, getting my first telescope and just pointing it at the sky and not even really knowing what I'm looking at, but still being fascinated and just seeing everything that happened, through the Voyager spacecraft. That kind of dates me, and then the beginning of the shuttle program. It all just kind of stimulated me to always follow an interest in space, and I've never really lost that in both in space and astronomy. And I like to kind of share that with other people too.
I'm thinking back, I had a telescope when I was a kid, right? And so I just remember never figuring out how to use it. It either was a really crappy model or something, but I would look in and I could see the moon maybe, but it was like this cardboard tube. It felt like with like some kind of magnifying glass. I don't know, but I was so excited. I just remember being so excited to go out and be able to see that, and I saw nothing. So
Yeah, I can relate.
So for those that haven't met you yet or don't know you that might be listening, I believe at one time you worked in industry first, right? Before you worked for the university. I want to say Boeing. Am I right in that?
Yeah, that's correct. I worked for Boeing on the International Space Station project back when the entire International Space Station pretty much was at Kennedy Space Center, and we were preparing all of the elements to get launched into space on their individual missions.
So
So that was in the 90s. Yep.
Right. So you worked in the world's flattest room, right? The room that touted the most flat floor on the face of the earth. Could you elaborate on that?
Yeah, that was in a building called the Space Station Processing Facility. The tremendous, ingenious way that NASA has in naming things. But
it was a marketing stop, right? It was a stop
right.
on the tour.
Yeah, absolutely. We had several glass windows in the high bay, which is basically kind of a massive clean room where we were working on all the elements. And the tourists would come in there on the bus stop, and we were in our bunny suits, and we'd sit there and just kind of wave up at them, and they would love that and take pictures and eat it all up. And so it was a good way to kind of relate to people, even if we were separated by glass.
Right. Now, am I right in remembering that you worked in the modules where the astronauts reside, not on the trusses or the power, the solar panels, any of that? You were actually working on the modules that required ECLS and, all of the human life support systems.
Right. Yeah. The pressurized modules that the crew members would live in then when the station was assembled on orbit, such as the United States lab module that is now called the Destiny module, for instance. And so, yeah, that's why we had to be in our bunny suits, because we didn't want to leave debris behind that would maybe float around and the astronauts could even breathe it in or get it in their eyes. And so it had to be a pretty clean and pristine environment.
Right. Now, did you have your doctorate before the ISS or after your time working on the ISS?
No, actually, I only had a master's degree at the time when I was working on the ISS, but I was taking advantage of some of the Boeing educational benefits. And so they always had some really good benefits. And so to me, it really would have been foolish not to keep going to school if somebody was going to pay the bill. And so I took advantage of that.
Well, I was going to say, so for some of our listeners, they might not realize that oftentimes you don't have to have a full degree necessarily before you go and work for a company. But if you get in with the right company, you can actually be working at the same time that they will help you get your degree. Is that what you did?
Yeah, for the most part. I mean, I did have a bachelor's degree in my first master's at the time, but you're absolutely right. In fact, many students will do an internship, for instance, at say NASA, for instance, and get in the door while they're still doing their schooling, and then that kind of filters into a full-time position afterwards, and so they can keep moving forward in either the company or the organization. And so that is absolutely a great way to do it if you can do that.
Right. Well, I'll just bridge over to the first time I met you, which I believe was 2016 Small Sat conference. when you were there with your company. I believe I'm saying it right, Micro Aerospace Solutions. Did I get that
Yes,
right?
that's right. Yep.
And you still have the same booth even today at Small Set, which is in a great location, right? Great location.
Right.
Tell us a little bit about Micro Aerospace Solutions. What made you decide to start a company? What's the focus of your company, and what you have planned for the future?
Sure. Yeah. So I decided that I was kind of interested in doing some level of consulting while I was actually still working out at Kennedy Space Center. And so in order to do that, say part-time in a non-conflicting type of arrangement, I would, need to have an avenue to be paid to do that. And so in 2000, I started a sort of a part-time company called Micro Aerospace Solutions. And so it's been around now about 23 years. And so it's been involved with a variety of different types of small satellite systems, including propulsion, electronics, avionics, and software are sort of the main areas. And one thing that I was always interested in, especially in the early days, was finding ways to do propulsion on small satellites. And so at the Small Sat conference, I presented some of the first papers on the use of propulsion systems and CubeSats. And at the time, it was kind of met with some skepticism because everybody said, well, there's no way that the safety personnel are ever going to allow propulsion on these CubeSats. But of course, the CubeSats have kind of taken a life of their own. And so now we're really doing all sorts of amazing things with small sats in general. And of course, CubeSats have grown from tiny little satellites to bigger satellites now, and very capable satellites. And so one thing we're always interested in is applying commercial off-the-shelf technology to space, because the so-called COTS technology can really provide higher performing capabilities for these small sats. And that's really important, for as we move forward with these missions.
Right. So you were just ahead of your time, right? That there's always a
I
crazy
like to think
person-
so.
There's always that crazy person that says something until it's proven, and then they're just a genius, right?
For our listeners
Right.
who might not be familiar with what off the shelf means, can you kind of explain what COTS is and why it's so necessary?
Yeah, sure. So COTS and commercial off the shelf basically means, and those are parts that you can buy for commercial electronics. And so say you were designing your own circuit board and wanted to put your own parts on the board, well, you can go to a variety of different online stores, if you will, and buy those components. And in fact, they're the same types of components that companies like Apple or Samsung will put into their cell phones and other types of digital technology that's out there now. I mean, traditionally in space, they have used what are called radiation hardened electronics. And this is electronics that has gone through all sorts of additional testing to supposedly be safe for the radiation environment in space. But that also means they're extremely expensive and hard to procure. And that's not what we want when we're building thousands of satellites and at very low cost.
So it makes it easier access, essentially, then, it sounds like.
Yes.
In fact, the billions of dollars that went into the smartphone, development led us to something, I think Ames, I think they're the ones that flew the phone sat, right? They literally took the boards out of a smartphone and flew it in space to show that even smartphone tech was durable enough, at least for limited exposure. Let's jump a little bit. I'll share, after meeting you in 2016, you were pivotal in us getting our first CubeSat built. You really built the payload that we use. We wanted to do to fly these bacteria, and without your help, I don't see that mission having been successful. So I already know that you work well with kids, and you've been involved with a lot of students. And I know from our perspective, from middle school all the way through graduate students. Tell us about how you got involved with Florida Tech and maybe what some of your responsibilities are there.
Sure. So in fact, I originally grew up in Connecticut, and I got my undergraduate degree from Western Connecticut State University in physics and astronomy. But then I realized I really wanted to do space engineering. And Connecticut's not really a great place to do that. So I moved to Melbourne, Florida, and went to Florida Tech for a master's degree in a discipline called Space Systems, which is kind of a systems engineering degree. for all of the components for space systems. And so at that time, soon after I graduated, I was offered an adjunct position to teach one of the classes that I had taken, spacecraft computers and data systems. And so that was my first class that I taught at Florida Tech. And I kind of just, stayed there after that and got to be able to teach more and more different courses, to the point where eventually I was named the program director for the Space Systems program. And now associate professor of space systems and the director of the Spaceport Education Center, which is just outside the gate at Kennedy Space Center. And so we teach a variety of master's degrees, both in person and online, that have to do with space systems, space systems management, commercial enterprise in space. And so, and of course, now with the tremendous interest there is in space, it's a very popular set of programs.
Right.
Do you also have your company still on the side though, right? So that people can still
sure.
come to you. That's fantastic.
Yep.
So is it fair to say that most of your current clients or students, they are young professionals and we're either working for NASA or companies there on the Cape, and you're helping them get their, I guess, second level of education? Is that a fair way to describe what you're doing?
Yeah, that's totally accurate. Most of our students are involved at some level in the space program already. Although we have a few students like I was, who were interested in finding a way to get my foot in the door. And so they're looking at ways to get their foot in the door. So it's a great environment because you meet all these people that already do have their foot in the door, and that helps them to also get a position in the space industry. Yeah, so it really usually works out.
I would imagine your graduates have about 100% job placement.
Yeah,
they?
certainly nowadays. Absolutely. And in fact, another set of students we have are military personnel. And some of them are Air Force people that are looking to get a commission into the Space Force, or they're already in the Space Force and looking to move up the ladder. So that's definitely another area that is really burgeoning right now too.
I would imagine the staff at Patrick Space Force Base are some of your students. Is that true?
Yeah, absolutely. Patrick, and then in Colorado, out at Vandenberg as well in California. And we're kind of excited about the new announcements of the Space Force Training Center at Patrick. And so that kind of fits in well with all the things that we've been working on already in educating the workforce to improve their space skills.
That's right. For our listeners, recently it was announced where different deltas would be located, and it's a training delta. Is that right? Is it 10 or 11 training delta that's going to be at Patrick?
Right.
Awesome. So let's talk about your interest, and you sort of have one foot in education, one foot in engineering, and one foot in entrepreneurship, which is really similar to what we're wanting to do. We just work with a lot younger clientele, I think, than you do. Has that balance always been there, or is that something that the entrepreneurial stuff grew on you after you sort of pursued your vocation and then you worked on your education? But explain to us your Venn diagram, and do you anticipate your the elements pretty much staying the same, or are you looking in new directions, or what you're thinking there?
Yeah, so I think that really at first I didn't really anticipate being an entrepreneur, honestly. When I first started working at Boeing, obviously that's a large company environment and very different than an entrepreneurial environment. But then I moved on to another company called Bionetics, and we built small payloads that flew on the space shuttle and then eventually on the space station. And there I met some people that were more sort of entrepreneurial in nature, and they would do their own side things. And so that's actually how I started doing some entrepreneurial development work with them while I was working at Bionetics. And so that kind of ignited the bug in me to do entrepreneurship. But at the time, I was still also teaching. I never left that possibility. In fact, I started out at the local community college at the time, was called Brevard Community College, teaching computer courses, and then moved on to Florida Tech and just kept teaching ever since. So I've always had an interest in kind of being a mentor. I think it's important to pass your knowledge on to the younger generations. And I think there's no way I'm ever going to not do that in some way. And so I guess that's why I've always had multiple hats, because I've always loved all these different fields. And I guess it's wonderful that you can sort of apply all of them together and be involved in all of them. And especially if you can find ways to do things you love, then you probably aren't going to change that. I mean, it'll morph over time.
Right.
And, I'd definitely like to be more involved in the deep space crew exploration missions as we move forward, from a medical point of view, from a systems technology point of view, and see what can happen there. But always also do education and entrepreneurship all at the same time.
Right. I have a question. Perhaps you can share with us, as we move towards living and working on the moon. We know that radiation is much different exposure on the surface of the moon than, say, even in low Earth orbit on the ISS. Maybe you could give us some brief background on why, some really good work needs to be done in mitigating the radiation problems.
Yeah, well, even in low Earth orbit, although oftentimes people don't realize this, the Earth's magnetic field still provides a tremendous amount of shielding. And so even living on the International Space Station, you're in somewhat of a protected environment. But of course, as we go all the way out to the moon, then really the Earth's magnetic field has very little or no influence at that point. And so that means that basically you're exposed to all of the solar flares and particle events and things that are released by the sun over time. And even when that's not happening, then there's galactic cosmic rays that are on the surface of the moon too. So either way, you're going to be bombarded by radiation. And so we need to understand how to mitigate that, the true long-term effects of radiation on the human body, on our systems, on our technology. If we're going to stay there for a long period of time, we're going to have to grow food. And how does the radiation environment impact that as well? But there's another perspective there too, and that is the lower gravity environment. We're not even all that certain how the human body will react to living long-term in a 1/6G environment that's on the surface of the moon. And then as we move on to Mars, say a 1/4 or so gravity environment on Mars after that. So we got to do a tremendous amount of work. And in fact, I often tell people that Gemini is what paved the way for Apollo. It was basically a series of low Earth orbit missions that astronauts were trained on, and they developed the technology to enable the tremendous success that Apollo was. But I view the moon in a lot of ways as sort of like Gemini. We're never going to be able to be successful at Mars until we're really successful for long-term human habitation on the moon.
That's really good. And am I right? Some of your current research is about astronaut health, and that's
Right.
what your focus is
Yep.
right now. Is it more about monitoring, or are you looking at some countermeasures? And of course, we're not asking for you to share IP, but anything you want to share about that would be great.
Yeah. Well, I've always had an interest in this idea of the changing roles of astronauts as we move into deep space exploration. In fact, earlier today, the NASA channel was broadcasting a spacewalk that was occurring on the International Space Station. If you watch any of those spacewalks, you'll see that the astronauts are continuously talking to the ground, and they're relaying information and getting advice. And essentially, there's a two-way real-time interaction there.
Mm-hmm.
Now, of course, at the moon, that's going to be partially possible because we're only going to be maybe 1 or 2 seconds time delay. But as we move to Mars, we're going to get up to a 20-minute time delay. And so with a 20-minute time delay, it's going to be impossible to have a real-time interaction with the ground. So what happens if an astronaut gets sick, they have an injury, there's some sort of medical problem that they face? There's not going to be an ability to communicate real-time with doctors and other medical personnel on the Earth. So how do you capture enough knowledge, enough capability, and enough training and support that training to allow astronauts, and even maybe in some instances, astronauts who are not doctors, to provide medical care in the local environment in deep space? And so what kinds of tools, what kinds of information, what kinds of training are needed to enable these astronauts to successfully complete their mission with no longer that sort of lifeline of a real-time direct connection back to the Earth.
Do you think I mean, it's just inevitable that we'll have AI assisted astronauts
Yes.
out there? That is the future, isn't it? Maybe you know something
Where
that we
will it
don't.
not be? That just
But that makes
Yes.
sense, right? You take all the knowledge you can and something to process it and synthesize it into
Gosh.
usable. But I could see that because the joke is something's going on with Beetlejuice, right? No, something happened to Beetlejuice a long time ago.
Right.
The
Right.
light has been traveling to us. Whatever happened to Beetlejuice has already happened, right? But I do appreciate the fact that the astronauts, they'll have to be more
I hadn't thought about
autonomous.
that.
Yes,
They'll have to be
autonomy
more
is
autonomous.
critical. That's a critical word. Absolutely.
Well,
And
when you-
AI is going to support that, no doubt. And, you could think of it, if you're a Star Trek fan, the Hollow Doctor.
I'm all over that.
So basically we're going to have to do technology in some form, maybe not a total android such as that, but it does have to use artificial intelligence, deep learning, machine learning capabilities to decipher and to support the astronaut. And you can't just list then 500 pages of WebMD to the astronaut and have them go through and try to figure out the answer. It has to be real, true decision support to enable them to be successful.
So you do work, or some of your research is for the health of the astronauts. So does that include also some of the mental health aspects?
Well, that's going to be important as well. We're going to have the ability to monitor the astronauts and take into account both their mental and their physical condition. And so that all has to go to sort of a local medical chief officer, if you will. And that will have some level of artificial intelligence, if you will. There's probably going to be final decisions that are made by the crew members on board, but imagine if there's a situation where some sort of spacewalk or even Mars walk has to take place and one of the crew members is somehow incapacitated. That could be a physical incapacity, or it could be something to do with a mental state of mind at the time even. And so again, this type of technology has to support a final decision then as to whether this is the right time and the right personnel to conduct that part of the mission.
Well, so if we're talking about AI and the idea that that's already after, then why wouldn't we just send AI out instead of humans to do that? I mean, do we still,
Well, the AI has tremendous ability, but I think it has ability to do decision support. That's why I was careful to say the term decision support. I don't think we want to get to a situation where we lose that human capability to be adaptive, to think on the fly, to come up with answers that we hadn't anticipated previously. That's why we're still having airplanes with pilots that are at the controls.
right?
Even though they're monitoring in many situations and they're getting decision support from the technology, but they're still there.
Right. And it's well established. We're going to use robotics to try to de-risk some of our exploration. And that's very important. I think what you brought out today in my mind is how important it is the people that design the interfaces between the astronaut and the AI and the AI and the astronaut, the way the decision support information is provided, the way it's arranged or organized, or, when the astronaut needs help, how does the system inform their decision, especially if the astronaut has to make it.
Well, and will they have to be
I think that's very interesting.
I'm just wondering too, if they have to be hooked up, like in some way to where this AI could actually see any vital sign, be able to check that at all.
Right. Yeah, the AI is going to have inputs. Yeah, absolutely. So it's going to take inputs and help then in supporting the final decision about the next steps of the mission.
And that's not just inputs related to the astronaut physical well-being, but the environment that astronaut is in, right? The remote, sort of all the remote sensing data of that situation, plus the astronaut's bodily parameters, all have to come together, right? And probably keeping in mind, what is the mission? Why is the astronaut there? What is the purpose, and how important is it for that mission to be completed?
Right. 15 years ago, I kind of started this research with that in mind, really. How do you do decision support for the exploration part of the mission? And we've kind of extended that now to the medical part. But at the time, we were mainly interested in how do the astronauts know where to go? You know, say again on Mars, for instance, what are the important things to look at? What are the types of rocks they need to collect? What other types of data do they need to be concerned about? And again, there's not the ability then for a scientist on the ground to say, yeah, pick up that orange rock over there. That's the interesting one. So they have to have sort of that scientist in some sort of AI digital form with them in real time, even though they're not really with them in real time.
Right. So let's fast forward 10 years. You get a chance to ride a Starship up to Gateway or to go hang out in some place on the South Pole of the moon.
Yes.
Will you accept the ride?
Yeah, absolutely. Yeah, that would be a fun ride,
So
definitely.
you would too, Kevin?
Sure.
Yeah.
Roll my fat
Yeah.
body in a wheelchair onto that capsule and let's go. It
Well,
doesn't take a lot of
15 years ago, I applied to be an astronaut too. So yeah, so it's
I did 3
I'd
times.
love to go.
I'm a thrice rejected applicant. So, but
I
no,
got a job offer out of it, but that was it, and it wasn't
well,
from the
that's
astronaut
great.
office.
Well, you're certainly living in the right place at the right time for your skills. And it seems like I don't want to say you're fully leveraged, but you seem to be running in some really good domains in 3 unique ways, which is
Right.
awesome, right? You're working at Kennedy Space Center, you run an education program, you have a company on the side. My last question for you is this: have you had any of your graduate students that took sort of your path and went out and started their own companies? Do you have any grand companies, so to speak, that are a spinoff or somehow you trained those students?
Yes, actually. Yes, SAS, and I forget what the acronym stands for, but I had 2 students who started that company. And in fact, Wayne Hale,
Oh, wow.
the shuttle program manager, is working for them now to support some of their activities. So yeah, and I think there's probably been others.
So,
And I've also had students that have moved on to be, for a while, commanding officer of, at the time, it was still Vandenberg Air Force Base. And many that have done amazing things and are still doing amazing things all over the space industry. It's really amazing to see some of the things that they are doing and have done. I try to keep in touch with many of them on Facebook over
Yeah.
time. And it's always special to hear back from them, especially after a long period of time, and to see the amazing things that they have been able to accomplish. And I think they're special people, and they came to me as special people. I just kind of helped them along the way in some small way, but they would accomplish amazing things nevertheless.
well, but what you saw with the Bionetics guys that you were working with when you were younger is what they probably saw in you. So
Well, I'd like to think so. Yeah. And I always try to encourage them to mentor also,
right.
It makes
pay
me
it back and to mentor the younger people that are coming on, behind them.
I can hear, well, and you know that I'm not at all technical, but within most of the conversation, I was recognizing a lot of these words from Theo's paper when he wrote. So I could really see the influence that you had really with the wolf pack going on. Cause I'm looking, oh yeah, I remember reading that. That must be where the bit flip thing came up, right? The idea of radiation hardening.
I just know
Right.
that Theo got turned down twice from CSLI,
And then, but now he's
but it took
flying.
us a few years, but
Yeah.
it's still going to fly. And
No,
so
that's great. You got
yeah,
to stick to it. That's the thing with space. You got to stick
yeah.
to it.
Space is hard, don't quit. I just
Right.
want to thank you as we close. I want to thank you for all the support that you've given. I think we went 3 or 4 times to visit you in the fall to
Yep.
work on different projects, and I'm so looking forward to continuing to work with you. And I appreciate all that you're doing, and we just wish you
Yeah.
great success.
For sure.
No, thank you. I really appreciate working with all your students, and it's always fun to see what you're doing, because you do amazing things, and your team really is incredible in what they've been able to accomplish, and it's because of their leadership.
Well, that sounds like a great ending spot. But before we do go, if there's any plug that you want to give for any websites, if people are interested in reaching out to you, any university teams looking for COTS, or just even if you want to plug Florida International, right? Is it specific to
Florida Tech.
Florida
Florida
Tech.
Tech.
Florida Tech,
Yeah,
not.
they're rebranded.
That's right.
Florida
Florida Tech. I got to remember
Yes.
that.
Sure, yeah. Micro Aerospace Solutions, it's micro-a.net. Feel free to also email me at dplatt@fit.edu. And, I'd be glad to answer questions or talk to anybody.
Sure. Now, can students sign up like asynchronously, or do you have semesters that your courses are offered, and or should they just email you about any kind of academic endeavors?
Yeah, they can email me. Our program does go on a semester basis. We have 3 semesters a year, and so it kind of goes in a synchronous fashion there. But we have all of our courses are virtual, so they can take them from anywhere, or if they're around the Melbourne and Kennedy Space Center area, then they can take them face to face too.
So I guess I do have one final question, actually, now that we're talking about that. So why Florida Tech versus another school?
Well, I think it was the space systems degree that really got me there, because I just saw it as a degree that was multidisciplinary, and I always like to think of myself as multidisciplinary. And so that's what first attracted me to Florida Tech in the 90s. And so I've just kind of kept moving that program forward because it's kind of it's entwined in me. It's part of my DNA, I guess, at this point.
Well,
Fantastic.
this was great catching up with you. We look forward to talking with you again soon.
Great. Thank you.
Thank you.